Okay, so get this. NASA's Lucy spacecraft. It's about to pull off a move straight out of a sci-fi movie.
Oh,
Yeah, it's going to use Earth's gravity like a slingshot to kind of rocket itself towards Jupiter's Trojan asteroids.
oh.
Crazy, right?
It is a pretty wild maneuver, that's for sure. And what makes this mission even more incredible is that those asteroids, they're like time capsules from the early solar system.
Oh, wow.
Yeah, billions of years old. And Lucy is going to be the first, you know, up-close look that we get at them.
So to get there, it's doing this gravity assist thing on December 12th.
Right.
What exactly happens during one of those? Like, is it as
Oh.
simple as it sounds?
I mean, the basic idea is to use a planet's gravity to alter a spacecraft's path
Okay.
and speed. So Lucy is going to swing by Earth incredibly close, like really close.
How close are we talking?
220 miles above the surface.
Whoa.
That's lower than the International Space Station.
Oh, wow.
So as it whips around us, it picks up a ton of speed,
Oh, okay.
basically stealing some of Earth's momentum.
Okay. I am picturing, like, a cosmic game of billiards, except
Okay.
instead of a cue ball, we have a planet.
Right.
But seriously, how do they even calculate something like that? Like, without Lucy running into, a satellite or something?
Well, that's where the incredible skill of NASA's navigation team comes in.
Okay.
They have to map out that trajectory, with pinpoint accuracy, taking into account all the objects in Earth's orbit.
Right.
And remember, Lucy is going to be traveling at over 33,000 miles per hour
Wow.
during this flyby.
That's insane.
Yeah, a delicate dance, to say the least.
That's a speed I can't even fathom.
Yeah.
So if we wanted to actually, see Lucy as it zooms by,
Oh, yeah.
is that even possible?
So unfortunately, the approach won't be visible because of, the sun's glare.
Ah.
But there will be a few chances to spot Lucy after sunset,
Oh, okay.
especially, if you have a telescope.
Mm-hmm.
Places like Hawaii and parts of Africa and South America.
Gotcha.
Those will have the best views.
We actually have a link to a site with all those viewing times in the source material for this deep dive.
Oh, perfect.
Definitely worth checking out if you're, in one of those areas. I imagine it'll be a pretty quick glimpse, though.
It will be. But think about it. You'd be seeing a spacecraft that's about to unlock secrets about the birth of our solar system.
That's true.
Even a fleeting glance is pretty cool when you put it like that.
Yeah, totally. So we've talked about the gravity assist, being like a slingshot, speeding Lucy up.
Right.
How much of a boost are we talking here?
So this maneuver, it's going to increase Lucy's speed by over 16,000 miles per hour.
Get out of here.
Yeah. And that extra push will help fling it, further out into the solar system towards its targets, those Trojan asteroids.
Okay.
It's really remarkable how we can use, like, the physics of the universe
Yeah.
to our advantage like this.
I know. It's kind of blowing my mind.
Yeah.
You mentioned Lucy's targets. Are we talking about just the two groups of asteroids we discussed earlier? Or are there any, stops along the way?
So before Lucy even reaches the Trojans, it's actually got a meetup with another asteroid. In 2025,
Right.
it's a main belt asteroid named Donald Johanson.
Donald Johanson, huh?
Yeah.
No, why does that name ring a bell?
So Donald Johanson was the paleoanthropologist who discovered the famous Lucy skeleton, the early human ancestor that the spacecraft is named after.
Okay.
It's a nice little tribute.
Well, right.
Yeah.
So Lucy the spacecraft is going to visit an asteroid named after the person who discovered the Lucy skeleton.
Exactly.
Okay, that officially qualifies as a cool fact for this deep dive. Speaking of Lucy's past, this isn't its first, close encounter with Earth, is it?
You're right. Back in 2022, it performed a similar gravity assist.
Oh, wow.
And during that flyby, it even captured some images of Earth and the moon.
Hold on, I actually remember seeing one of those pictures.
Yeah.
The one of Earth, right?
Uh-huh.
It was amazing. Wasn't it primarily for, instrument calibration?
It was, yes.
Oh.
But even with a practical purpose, it's still amazing that we have this spacecraft out there taking pictures of our home planet
Yeah.
while on its way to explore ancient asteroids.
I know.
It's pretty awe-inspiring when you think about the scale of it all.
It really puts things into perspective.
Right.
And that picture, even though it was, just for calibration, it really stuck with me. I remember thinking about the journey Lucy was on, how far it had already come and how much further it had to go.
It's a journey that'll hopefully teach us a lot
Right.
about the history of our solar system and maybe even ourselves.
I like that.
Yeah. So we've talked about, this incredible journey that Lucy is on.
Right.
But let's dig a little deeper, shall we? Into the destination. Those mysterious Trojan asteroids.
Okay.
You're probably wondering, what makes them so special, right?
Honestly, when I first heard about them, my mind went straight to, like, ancient Greece and giant wooden horses.
Oh, yeah.
I'm guessing it's a little more complicated than that.
Well, the name does come from the Trojan War, but no wooden horses involved.
Good.
It's because these asteroids, like the armies in the conflict, they're divided into two groups.
Okay, two groups of asteroids.
Right.
But where are they exactly, and why are they, like, huddled together?
So they share Jupiter's orbit around the sun.
Okay.
One group, the Greeks, they're clustered ahead of Jupiter, and the other, the Trojans, they trail behind it.
Gotcha.
So imagine it, like a cosmic dance with Jupiter leading the way and these asteroid groups, following in formation.
So they're, like, stuck in Jupiter's gravitational pull, kind of caught in this, like, celestial waltz.
Exactly.
Okay.
And what makes them so intriguing is that they've been trapped in these stable points, in Jupiter's orbit.
Right.
For billions of years, virtually untouched.
So they're like pristine time capsules.
Yeah.
Holding secrets from the very beginning of our solar system.
Precisely. Scientists believe they formed in the outer reaches of the solar system.
Wow.
Way beyond Neptune. And then they migrated inwards during a period of, like, planetary upheaval.
Wow. Talk about a long, strange trip.
Right.
So they weren't always, like, hanging out with Jupiter.
Nope. They've been on a wild ride through the solar system.
I bet.
And because of that journey, they hold clues to the conditions and processes. That shaped everything we see today.
Wow.
Including our own planet.
Okay.
It's like they witnessed the solar system's, dramatic origin story firsthand.
Okay, so Lucy is going to visit both these groups, right?
That's right.
But how can we possibly learn about the solar system's formation just from, like, looking at these asteroids? What exactly is Lucy looking for?
Well, Lucy is a high-tech detective equipped with a whole suite of instruments.
Oh, cool.
So it can analyze the asteroid's surface composition, map their geology, even measure their temperature.
So it's like a flying laboratory beaming back data from these ancient relics.
Exactly. And by analyzing this data, we can learn about the types of materials that existed in the early solar system, the processes that led to the formation of planets.
Right. So it's like piecing together this giant puzzle with each asteroid holding a clue.
That's a great analogy.
Thanks.
And, who knows? We might even find clues about the origins of life itself.
Whoa, hold on.
Yeah.
Origins of life? What do asteroids have to do with that?
Well, we know some asteroids contain organic molecules.
Okay.
The building blocks of life, right?
Right.
So it's possible, just possible, that these Trojan asteroids could provide insights into how those molecules ended up on Earth. Maybe they played a role in kickstarting life as we know it.
Okay, now that's mind-blowing.
Yeah.
So these ancient rocks, hurtling through space for billions of years, they might hold the key to our very existence.
It's a humbling thought, isn't it?
Yeah.
And that's what makes this mission so exciting. I mean, we're on the verge of unlocking some of the universe's biggest mysteries.
I'm definitely getting that stay tuned feeling. Because I have a feeling the discoveries are just beginning. I'm still kind of reeling from that whole idea.
Right.
That these asteroids could hold clues to the origins of life.
It's pretty wild.
It really is. It's amazing to think that Lucy's out there right now gathering this information that could rewrite, like, all the textbooks.
Yeah, it is truly remarkable. But, it kind of raises an interesting question. Like, why should we, down here on Earth, care so much about these ancient rocks billions of miles away?
Yeah, that's a fair question. I mean, it's fascinating from, like, a scientific perspective.
Of course.
But does it really, impact our lives here on Earth?
Well, I mean, there's the, pure pursuit of knowledge.
Right.
Of course.
Okay.
Understanding our origins, our place in this vast universe.
Yeah.
It's a fundamental human drive, right?
Right. It's like that same curiosity that led our ancestors to, sail across oceans and explore new continents.
Exactly.
Right.
It's like we're hardwired to explore.
Yeah.
And make sense of the world around us, even on a cosmic scale.
I can get behind that, but are there, like, more tangible benefits to studying these asteroids?
Oh, absolutely. Yeah. Think about it. By studying the composition of these asteroids, we might find resources that could be valuable to us in the future.
Like what?
Well, some asteroids are rich in metals and minerals that are becoming scarce here on Earth.
So you're talking about like the possibility of space mining.
Mm-hmm.
It sounds like something straight out of science fiction.
I know. It might seem far-fetched now, but it's a real possibility down the road.
Wow.
And, who knows what other resources we might discover out there, right? The asteroids could hold the key to solving some of our, resource challenges here on Earth.
Huh. I never thought about it that way.
Right.
It's like the asteroids are this like untapped treasure chest just waiting to be explored. But if we're talking about like potential benefits, is there anything more immediate, more relevant to our lives, today?
There is, actually.
Really?
Yeah, and it's something that has very real implications for the future of humanity.
Okay, lay it on me.
I'm talking about planetary defense.
Whoa. Okay,
Yeah.
Now things are getting serious?
Yeah.
Are we talking asteroids hurtling toward Earth? End of the world scenarios?
Well, let's not get too dramatic.
Okay.
But the principle is similar. By studying, the composition and trajectories of asteroids, we can better predict and potentially even prevent any future impacts with Earth.
So Lucy's mission isn't just about, looking back in time.
Right.
It's also about protecting our future.
Exactly. The data Lucy gathers could be crucial for developing strategies to deflect any potentially hazardous asteroids.
Wow. So it's like we're getting an early warning system for the planet.
Mm-hmm.
Wow. This mission really does have implications for all of humanity.
It does.
I had no idea.
Yeah. It's a reminder that space exploration, isn't just about scientific curiosity. It's about understanding our place in the universe and ensuring our continued survival, right? It's about looking back to understand our past and looking forward to protect our future.
That's a pretty good way to put it. It's almost poetic.
Yeah.
This little spacecraft,
right,
named after one of our earliest ancestors, could hold the key to understanding, both our origins and our destiny.
It really is a remarkable thought, isn't it? And as Lucy slingshots past Earth on December 12th, remember that it's not just a spacecraft on a mission. It's a symbol of our, insatiable curiosity, our relentless pursuit of knowledge, and our commitment to safeguarding our planet.
Well said. And as we wrap up this deep dive, I'm left with a sense of like awe and wonder and a renewed appreciation for the incredible work being done by, scientists and engineers all over the world.
And I'm left with one final thought-provoking question for you. And for everyone listening. What secrets do these ancient Trojan asteroids hold? And what will they reveal about the grand story of our solar system and our place within it?